A Brief History of Physics in Trinity College is based on the book 3 Centuries of Physics in Trinity College, Dublin by Eric Finch, Fellow Emeritus. In the beginning, Trinity College Dublin received its royal charter from Queen Elizabeth in 1592. Physics as a defined subject in Trinity College can be dated from 1724 with the establishment of the Erasmus Smith's Professorship in Natural and Experimental Philosophy. Erasmus Smith was a rich English merchant and a landowner with possessions in England and Ireland. After the Restoration of 1660, he set up an educational trust out of profits from his estates. Richard Helsham was the first professor of physics in Trinity College, Dublin. He was an accomplished polymath who was a trained medical doctor as well as a physicist. By 1711 he was lecturing in experimental philosophy, the name given to the subject that we know today as physics. He was a physician and a personal friend to the author Jonathan Swift. Richard Helsham held a wide range of intellectual interests. In 1734, a lodestone, a piece of the mineral magnetite which is naturally magnetized, was presented to and used by Helsham to investigate various properties of magnetism very early on in the field. The 300-year-old lodestone is still with us and currently on display in the Fitzgerald Building of Trinity College. Richard Helsham is best known for his posthumous publication of his course of lectures in natural philosophy. It was published by his colleague Brian Robinson in 1739 after Richard Helsham's death. It was one of the first textbooks in physics for undergraduates covering Newtonian physics. It was used by students right up until 1849. The current copy on display in the Fitzgerald Building is a first edition and was previously owned by William Jones. He was a personal friend of Isaac Newton's and the first to use the symbol pi for the ratio of the circumference of a circle to the diameter, as well as recognizing that it was an irrational number. There is evidence of William Jones's handwriting in the book. The 19th century, the golden age for physics, is remembered for several famous and internationally renowned Trinity physicists, including William Rowan Hamilton, Humphrey Lloyd, James McCulloch and George Francis Fitzgerald. William Rowan Hamilton was a child prodigy and even took up the role as a professor of astronomy while still an undergraduate at Trinity College. He worked and resided at Dunsink Observatory. His contribution to physics and mathematics is vast, including the fields of optics, mechanics and algebra. Hamilton first theorized about the principle of conical refraction, where light is refracted and emerges as a hollow circular beam from a crystal. Later it was realized experimentally by Humphrey Lloyd. This was one of, if not the first mathematical prediction of a physical property that was subsequently confirmed by experiment. The conical refraction demonstration is exhibited in the Fitzgerald Building in the School of Physics, Trinity College, Dublin. Humphrey Lloyd will be most recognized for his experimental work in the field of optics. He demonstrated for the first time the conical refraction predictions of Hamilton in a crystal of aragonite. This was also an early demonstration of the wave nature of light. Lloyd also made investigations into the Earth's magnetic field and constructed a magnetical observatory in Trinity. It was located close to where the Long Room hub is currently situated. James McCulloch in his short and tragic life contributed greatly to the field of optics and geometry. He was a brilliant mathematical physicist, and his work on the propagation, reflection and refraction of light waves in crystalline material was a major achievement, and was adopted as the standard until Maxwell's work on electromagnetism along with Einstein's theory of relativity. George Francis Fitzgerald is best known for the Lorentz-Fitzgerald contraction. He was an influential figure and one of the Maxwellians who supported the new Maxwell theory of electromagnetism. His uncle, George J. Stoney, another Trinity graduate, gave the electron its name and made an early estimate of the charge of the electron. It was largely due to Fitzgerald's advocacy that the physical laboratory was built in 1906. The building is now named the Fitzgerald Building in his honor. In 1895, Fitzgerald attempted to fly in College Park using a German Lilienthal glider, the first in Ireland and Britain. He partially succeeded, with the Irish Times newspaper reporting, "At last one attempt was successful, the machine being raised about 2 feet from the ground, and, aided by a brisk breeze and the professor, were carried for a short distance." Ernest Thomas Sinton Walton was one of the leading figures of 20th century physics, whose 1932 experiment, splitting the atom, with Cockcroft at the Cavendish Laboratory in Cambridge, was one of the milestones of the modern subject, and earned them the Nobel Prize. He was a graduate of Trinity and returned to the college in 1934 with the hopes of continuing his research. Due to the impoverished state of the physical laboratory at the time, Walton was not able to develop his research further as he would have liked. He could have easily moved to a better funded position, but he was far too fond of Ireland to wish to leave it. In 1943, a series of 3 public lectures entitled "What is Life?" were presented in the Physics Lecture Theatre of the Fitzgerald Building of Trinity College by Erwin Schrödinger. The lectures were published as a book in 1944 and inspired James Watson and Francis Crick in their work in discovering and understanding the double helix nature of DNA. Brian Henderson was appointed the 19th Erasmus Smith's Professor of Natural and Experimental Philosophy in 1974. He was responsible for bringing in significant funding to help modernize the department and expanding the academic staff, and thus left the School of Physics flourishing after he left in 1984. During the 1980s, the School of Physics continued with strong momentum to expand, and with enthusiastic and innovative engagement with industrial partners, it thrived into the 90s and the new millennium.
Interaction with industry is very much part of the spirit of the age for universities. We are certainly not unique, although we would hope that in many respects we are in the lead in pursuing that interaction.
As a result, throughout the 80s, Trinity College moved ahead of the times and developed its innovation culture, a movement to carry the fruits of research into the development phase. The university's Innovation Centre was thus established with the help of the IDA, and it functions mainly to foster and promote new relationships with industry, and in doing so has attracted government support through a variety of new mechanisms, including those initiatives by the new Minister of Science and Technology. We have also direct links with the Department of Industry and Commerce, who established Optronics Ireland. We have links with the scientific agency OLIS, We have partnerships across Europe with major industries in the framework programme of the European Community.
Investigate the behavior of optical and electronic materials. The laser facilities are extensive, ranging from a powerful laser welder for materials processing to ultra-short sub-picosecond pulsed lasers for studying nonlinear and dynamical phenomena. Much of this research is carried out in conjunction with Optronics Ireland, a national program for the development of advanced optoelectronics technology. This combination of laser light and electronics is already revolutionizing our lives, from telecommunications through to computers. OLIS, the Irish Science and Technology Agency, and the Japanese electronics company Hitachi are examples of two important institutions who have realized the great potential of this optoelectronic research. To assist in its research, Hitachi set up its Dublin-based laboratory on the Trinity campus. Working closely with the physics department with its knowledge of quantum well devices and optics, and using Hitachi's own expertise in computing, they developed an optical neural visual recognition system, which was recently announced in a worldwide press release. Such innovation may also be seen in other areas, such as magnetism and superconductivity.
Our work is centered in the areas of magnetism and superconductivity. And those are both two fields where there have been spectacular advances in the last 10 years. I guess that many people will be aware of some of the high-temperature superconductors that we're working on. But what's not quite so well known is the fact that magnets have been improving. They've been doubling their performance every 15 years since the beginning of the century. You can see, if you look over here, an 18th century lodestone, which was presented to the college for experiments in natural philosophy, and beside it a ferrite magnet, the type you've got on your fridge door, and then a modern rare earth iron magnet. Now, each one of those three magnets produces about half a joule of energy. So you can see that the amount of material required has decreased by about 200 times in that period.
Professor Coey's research, concentrating on improving the performance of magnets, has many important practical applications. Such innovation may also be seen in research work of the Polymer Physics Group.
What we have here is a state-of-the-art nuclear magnetic resonance spectrometer. It provides very critical information on materials of strategic importance to industry, and it has been the source of several patents for us here in Trinity College. Typical examples would include the study of the interaction between carbon black and rubber, and this is very central, for example, to the manufacture of tires used in cars. Another example that has created several patents involves work that we have done on polymers that are used in the manufacture of contact lenses. This work is central to the needs of industries like Bosch and Lohm, which have a subsidiary in Waterford, and indeed we liaise very closely with the research people at the head office. These examples are very clear indicators of the very short step between fundamental research as carried out in a university and the creation of important intellectual property of immediate interest and application in industry.
These vibrant research activities provide an exciting backdrop to the department's teaching program.
Over the past 50 years, funding for research from the Irish government, the European Commission and industrial partners has increased. Consequently, many vigorous research programs have developed over time in photonics, magnetism, nanoscience, condensed matter physics, soft matter, astrophysics and quantum science. The Department of Pure and Applied Physics was renamed the School of Physics in 2005. The interests of the school are spread over many research centres, and many of its researchers are part of the Sami Nasser Institute for Advanced Materials, opened in 2000, and the Centre for Research on Adaptive Nanostructures and Nanodevices, established in 2006. Thank you for listening. I hope you enjoyed this brief history of the School of Physics in Trinity College, Dublin. If you would like more information of the school or the courses they offer, please visit the website www.tcd.ie/physics.